Florida's lake drains to cracked mud. 400,000 people's drinking water disappears underground. Those words sound like a dramatic headline, but in North Florida right now, they are not an exaggeration. They are a literal description of what just happened to Lake Jackson, a 4,000-acre lake outside Tallahassee that has gone from open water to cracked mud and stranded lily pads in less than half a year. Imagine waking up one morning and realizing the lake your community has lived beside for generations is gone, not flooded, not polluted, drained into a single 28-foot hole in the bottom of its own basin. 12 billion gallons of water have disappeared underground in roughly 5 months, funneled into the Floridan aquifer that supplies drinking water to nearly 400,000 people. And the strangest part is not just that the lake vanished, but where that water is going now, and what is waiting at the other end of the underground river it has joined. Right now, people are walking across what used to be open water. They are climbing down into the sinkhole at the bottom of the dry lakebed, standing on rock that has been buried under more than 20 feet of lake water for almost every year in living memory. The National Weather Service has already placed the region under extreme drought. The local water managers have issued one of only 3 water shortage warnings they have put out in the last quarter century. This is not just a weird local story about a disappearing lake. It is a warning signal about an entire hidden water system that millions of people depend on, and about a cycle that is speeding up in ways the data cannot fully explain. So the questions hanging over Florida tonight are simple and terrifying. How long will Lake Jackson stay gone? Why is the drain cycle accelerating? And what does it mean when one of the largest springs on Earth suddenly begins receiving 30 days' worth of an entire Florida lake? To understand how a lake can just drain away, you have to start with the moment the plug in the floor gave out. The drain began in Thanksgiving week of 2025, during late November, when the Big Bend of Florida had already been in deepening drought for months. Stormwater that would normally refill Lake Jackson stopped feeding the basin. Day after day, evaporation kept pulling water off the surface. On the bottom of the lake, in a section known as Porter's Sink, the sediment plug that usually seals the floor started loosening. By November 30th, Rob Diaz de Villegas, an ecology producer for public media in Tallahassee, was standing at the lakeshore at sunset, taking photos of water cascading down into Porter's Sink like a bathtub emptying. 2 days later, on December 2nd, the basin beneath that part of the lake stood exposed. A 28-foot deep, cavernous sinkhole stared straight up at the sky where water should have been. A brief rainstorm refilled the lake for less than 2 weeks, hiding the hole. By January 6th, it drained again. By March, vegetation began sprouting across the lakebed. By April 20th, when a photo crew visited from the local newspaper, Lake Jackson, which normally measures 6.2 square miles at full pool, was, in their words, almost completely dried up. A bobcat was caught on camera sprinting across what used to be a boat ramp. And on May 4th, 2 men climbed all the way down into Porter's Sink itself, searching for fossils in the rocks at the bottom. If you zoom out on a map, the geography makes the mechanism clear. Lake Jackson sits in northern Leon County, Florida, just off Interstate 10, about 10 minutes from downtown Tallahassee. It is what geologists call a karst lake, a body of water that rests on top of dissolved limestone. There are no rivers feeding this lake, and no visible outlets carrying water away. Instead, Lake Jackson occupies a closed basin roughly 42 square miles in area where rain pools in and slowly evaporates. 2 natural drain plugs sit in its floor, Lime Sink at the north end and Porter Sink at the south. When those plugs hold, the basin fills and you have a lake. When the plugs fail, the lake has nowhere to go but straight down. The part the headlines miss is that the water draining into Porter's Sink is not gone forever. It is being routed through a hidden highway under the ground. Harley Means, the state geologist of Florida, climbed down into Porter's Sink himself during a drain back in 1999. He compares Lake Jackson to a checking account. When more water comes in through rainfall than leaves through evaporation, seepage, and the sinkhole, the account stays positive and the lake rises. When the deposits stop, the balance falls and the lake drains. That analogy makes sense on paper, but it hides the most important detail of all: where that water actually travels once it drops into the sink. In 2018, a team led by Dr. Sean McGlynn of McGlynn Laboratories, who also chairs the Wakulla Springs Alliance, decided to trace that hidden journey. They poured tracer dye directly into Porter's sink. The dye flowed south, traveling 30.6 kilometers, about 19 miles, through the labyrinth of the upper Floridan aquifer beneath the surface. 35 days later, the dye emerged in Wakulla Spring, one of the largest first-magnitude springs anywhere on Earth. Average speed underground was about 0.87 kilometers per day. In other words, Lake Jackson is not disappearing. It is moving, slowly and invisibly, under more than a dozen miles of pine forest and karst plain to resurface at one of the most famous springs in the world. Once you know that, the story stops being just about one lake and becomes a story about an entire regional water system operating like a hidden circulation loop. Lake Jackson acts as a surface reservoir perched above the Floridan aquifer, feeding it directly when the sinkhole opens. Wakulla Spring is one of the major outlets where those underground waters reappear in the open air. Every gallon that slips through Porter's sink during drought is simultaneously vanishing from lakeside backyards and becoming part of the flow burst that drives an iconic spring farther south. Historically, that cycle of draining and refilling happened slowly. For most of the last 200 years, Lake Jackson drained roughly once every 20 years. The native Muskogee name for the lake was Oki-Hipki, which literally means disappearing waters. Local records and geological notes documented draws in 1829, 1907, 1932, 1957, and 1982. It was like a long heartbeat. The basin would fill, the plug would hold, then once every couple of decades, the lake would vanish down the sink, leaving cracked mud and fossils exposed, before slowly refilling over time. Then, something changed. Since the late 1990s, the lake has drained partially or fully in 1999, 2001, 2006, 2012, 2021, and now again in 2025. The interval has collapsed from almost 2 decades to just a few years. It is no longer a rare once-in-a-generation event. It is becoming a recurring stress, slamming the lake and the aquifer beneath it far more frequently. And the 2025 drain cycle is not happening in isolation. It is colliding head-on with the worst drought in Tallahassee's recorded history. That combination matters because the Floridan aquifer is not just a geological curiosity. It is the drinking water source for nearly the entire Tallahassee metro area, around 400,000 people. In February of this year, the Northwest Florida Water Management District issued a formal water shortage warning. It was only the third alert of that kind in the district's history, with previous warnings in 2002 and 2007. All 5 of Florida's water management districts are now under simultaneous shortage warnings. Taken together, the state's water systems are running a deficit, pulling more out of the aquifer to serve communities than rainfall is putting back in. Lake Jackson did not just spontaneously vanish. It was, in a sense, set up to disappear by the longest dry stretch on record, falling on a basin that already had a weak point in its floor. Think about a house built over a drain. In normal years, the plug stays in place. The water level rises and falls a little, and everything feels stable. But if you go long enough without rain, if evaporation overpowers the inflow, and if the plug at the bottom keeps eroding grain by grain, eventually the drain becomes the only path left for the water to follow. The impacts begin right at the lake's edge and ripple outward. At Fox Drive Landing, the boat ramp now ends in mud where waves used to slap its concrete. Birders who once tracked waterfowl gliding across open water are instead tracking shorebirds, picking through cracked sediment. Fish populations like bluegill, largemouth bass, and gar have compressed into a handful of deeper surviving pools at places like Church Cove and McGinnis Arm. Chris Paxton, a biologist with the Florida Fish and Wildlife Conservation Commission's Freshwater Fisheries Division, has said that over the long term, refilling after a drawdown can actually benefit the lake's ecological health by resetting shallow habitats and nutrient balances. But that does not make the sight of 12 billion gallons of water leaving people's backyards any easier for homeowners to process. 12 miles south, a similar story is playing out at Cascade Lake near Tallahassee International Airport. Cypress trees that were submerged up to their knees a year ago now stand fully exposed. 10 feet up their trunks, a sharp band of pale bark marks where the water line used to be. It looks like someone traced a ring around the entire lake, showing the level nature has lost. Farther out across the system, the stakes grow even larger. The Floridan aquifer is already on the receiving end of heavier pumping during this drought, as utilities and communities draw more deeply to compensate for missing surface water. Wakulla Spring, which receives part of its flow from that aquifer and now from the drained waters of Lake Jackson, is already on Florida's list of impaired waters. Pollution, nutrient loading, and reduced flow have impacted its health. When Lake Jackson joins that underground river more often, it raises the question of what repeated pulses of lake water, with whatever it carries, mean for a spring that is already stressed. Underneath all of this sits an existential question buried in the Florida Geological Survey data and local drawdown records. If a lake that used to disappear once every 20 years now disappears every few years, what does that say about everything else built on top of the Floridan aquifer? Homes, roads, utilities, airports, neighborhoods, they all depend on the stability of the rock beneath them and the reliability of the water within it. An accelerating drain cycle suggests the system that holds both may be changing faster than expected. In the immediate term, everyone is looking up at the sky for relief. The National Weather Service Forecast Office in Tallahassee has said that a stalled cold front this week could bring between 1 and 3 inches of rain across the Panhandle and the western Big Bend. That rain is welcome. It will raise soil moisture, cool surfaces, and add some water back to the basin. But by the estimates of people like Dr. Sean McGlynn, it is almost certainly not enough to keep the sinkhole basin submerged for long. Lake Jackson needs consistent 3 to 6 inch rain events to meaningfully refill. Half-inch and 1-inch showers tend to evaporate before the next one arrives in heat like this. The Atlantic hurricane season opens on June 1st. A single tropical system, moving slowly enough and dumping enough rain at once, could refill Lake Jackson in a matter of days. There is precedent for lakes recovering dramatically after a major storm. But without one, the basin is likely to remain exposed through the summer. Vegetation will continue growing across the bottom. Fossils will stay visible inside the sink. And the Floridan aquifer will continue absorbing whatever rainfall the region can spare and whatever partial refill the lake manages to deliver. There is one more layer of uncertainty. Porter Sink does not stay open forever. Sediment and debris will eventually plug it again, the same way it has plugged itself at least half a dozen times over the last 2 centuries. The exact mechanics are messy. Storms drive material into the hole. Eroded grains settle. Chemical processes within the limestone shift. The plug reforms. But the timing is unknown. Nobody can say whether it will be months, years, or longer before the drain reseals and Lake Jackson is able to rebuild a stable water level without emptying straight into the aquifer. So 3 questions hang over the dry basin tonight like unanswered headlines. How long will Lake Jackson stay gone? Why exactly is the drain cycle accelerating, collapsing from decades to mere years? And what does it mean for Wakulla Spring and the entire Floridan aquifer when one of the largest springs on Earth is suddenly receiving 30 days worth of an entire lake's water, complete with everything that lake carried on its way down? the most haunting image might be the one you cannot see. The water that filled Lake Jackson on Thanksgiving morning is right now somewhere beneath the pine flats between Tallahassee and Wakulla, moving through limestone channels in the dark at less than a kilometer a day, making its slow, invisible journey toward the surface at Wakulla Spring. Porter Sink is still draining. The aquifer is still rising to meet it. And somewhere south of the lake, in the hidden rock beneath Florida's forests, the next 40,000 acre-feet of Lake Jackson is already on its way underground. Lake Jackson's empty basin is not just a drought story. It is a story about how fragile the balance is between the water we see and the water we never think about. When a lake vanishes into a hole in its own floor, it forces us to face a simple truth. Surface water and groundwater are not separate worlds. They are one system. When one part changes, the other responds, even if that response is invisible and delayed. The dye experiment in 2018 proved this beyond doubt. What looks like a sinkhole swallowing a local lake is also the start of a slow-motion flood into a distant spring that tourists visit without ever realizing the source of some of that water once lapped at backyard docks in Tallahassee. For people living around Lake Jackson, the emotional impact is almost as heavy as the physical. Many families chose their homes because of the view. Boats once sat at private docks, ready for weekend trips. Children grew up fishing from piers and watching storms ripple across the surface. Now, instead of open water, they see cracked mud stretching beyond the tree line. Lily pads sit stranded, high and dry, like someone cut the water out from under them. It feels as if a living thing has been removed from the landscape. Lakes create a sense of place. They anchor communities. Watching one disappear into a hole feels like losing more than just water. It feels like losing part of the identity of the area. Neighbors now walk where they once drove boats. Some hike across the dry basin, tracking animal prints in the mud. Others venture cautiously toward Porter Sink to see the opening in the earth that has become the center of the story. The sight from inside the sinkhole is surreal. Rock walls rise around you, scarred by ancient erosion. Above, the rim of the lakebed traces where water once stood more than 20 feet overhead. For fossil hunters like Matt Lisenby and Michael Sellers, the drawdown has turned the lake into a field site. They search for shells, bones, and other remnants that have been locked away underwater for decades. Each find is a reminder that this basin has been cycling between wet and dry for centuries, long before modern records. But even in the excitement over fossils and exposed geology, the broader tension remains. Every gallon that dropped through Porter Sink is part of the region's drinking water budget. The Floridan aquifer now holds that water, along with whatever pollutants, nutrients, or sediments traveled with it. Wakulla Spring, already labeled as impaired, will interact with those flows. When you stand at the spring and watch clear blue water surge from underground, it feels timeless. In reality, it is pulsing with the consequences of everything happening upstream and up basin, including the disappearance of Lake Jackson. This is why water managers watch events like this with a mix of scientific curiosity and deep concern. On one hand, the drain and refill cycle is natural. The Muskogee name itself, Oki-Hipki, shows that indigenous communities recognized disappearing waters long before anyone ran trace or dye through Porter Sink. On the other hand, the speed of the recent cycles, stacked on top of record drought and increasing groundwater pumping, suggests that nature's old rhythms are colliding with new pressures. When a 20-year cycle compresses into 5-year or 3-year spans, it does not just affect one lake. It hints at larger changes in how water moves, how rock responds, and how the entire aquifer behaves under stress. For Tallahassee and the surrounding metro, this matters because the aquifer is their lifeline. Turn on a tap, and you are directly connected to that underground reservoir. If heavy pumping continues through drought while surface lakes drain more often, the balance between recharge and withdrawal can tilt in dangerous ways. Wells can start to drop. springs can see reduced flow. In some extreme cases, rapid changes in water levels within limestone can even destabilize parts of the ground itself, increasing the risk of new sinkholes forming in unexpected places. At the same time, the accelerating drain cycle forces planners and scientists to think about adaptation. What does it mean to design communities, roads, and utilities in a region where major lakes might vanish suddenly every few years? Boat ramps, docks, marinas, and lakeside parks are built for water. When that water disappears, those structures sit stranded in dust. Do you plan for flexible use that can shift from lake recreation to open basin exploration? Do you invest in alternate reservoirs or storage systems that do not depend on one lake staying full? These are the kinds of questions that move from theoretical to urgent when residents find themselves staring at cracked mud instead of waves. Even for ecosystems, the drain and refill cycles are a double-edged sword. On one hand, temporary drawdowns can reset shallow habitats, reduce overgrowth of certain plants, and release built-up nutrients. When water returns, fish and invertebrates can recolonize a refreshed environment. On the other hand, increasingly frequent or intense drains compress fish into small refuges, stress wildlife, and expose bottom sediments long enough for invasive plants to gain a foothold. The balance between helpful reset and harmful disruption depends heavily on timing, duration, and what the climate does next. So where does this leave the people living with Lake Jackson's absence right now? In a kind of waiting room between sky and stone. Everyone knows that the basin will eventually refill. They know that Porter Sink will eventually plug, at least partially. They know that the rain will come, whether through scattered thunderstorms or a major tropical system. The uncertainty lies in when and how extreme that refill will be. If the lake stays dry through the heart of summer, vegetation across the bottom will expand, potentially changing the character of the lake when water returns. If a slow pattern of storms builds up the level gently, the transition back to a full lake might be gradual. If a single stalled tropical system dumps massive rain in a matter of days, the refill could be dramatic, with rapid changes in shoreline, erosion, and water quality. In the meantime, one quiet reality remains constant. While residents look out across cracked mud and stranded pads, their missing lake is already part of another landscape, underground, on its way to Wakulla Spring. The water they once saw every day is moving in darkness through limestone channels that have carried Florida's hidden rivers for longer than recorded history. It is traveling slowly, at less than a kilometer per day, but it is moving. When visitors stand at Wakulla and marvel at the flow, they are watching pieces of Lake Jackson arrive, day after day, mixed with other sources, all contributing to the spring's powerful surge. That image ties the entire story together. A lake that disappears is also a lake that migrates. It shifts from being a visible surface feature to being part of an invisible underground river, feeding a distant spring and sustaining a city's water supply. The accelerating drain cycle, the worst drought on record, the water shortage warnings, the exposed cypress trunks, the fossils now reachable inside Porter Sink. All these details point toward a single message. Florida's water system is dynamic, sensitive, and deeply interconnected. What happens at one lake does not stay there. It travels, echoes, and resurfaces in ways that matter for hundreds of thousands of people. So as Lake Jackson sits empty tonight, with Porter Sink still pulling water downward, the real story is not just about loss. It is about connection and about time. The water that left the lake months ago is still moving. The plug that failed will one day reform. The basin that cracked into mud will, at some point, flood again. Between those moments, the region's choices about how it uses water, how it prepares for drought, and how it understands the ground beneath its feet will decide whether the next disappearance feels like a bizarre natural spectacle or like the latest warning in a series we can no longer afford to ignore.